Hi viewers, today we are going to see the problem number 7, that is a cantilever beam which is carrying the loads of UDL 2 with a 2 meter span of one and a 3 meter span of another UDL, which is the magnitude of 4 kilonewton per meter and a 3 kilonewton per meter. For this we are going to draw the shear force and bending moment diagrams. As we know already, we are having a 5-step method. 5-step method. One is given data, here given data, total load on beam, equating upward reactions is equal to downward reactions, that is the loads we are having, what we are having here, UDL loads, and shear force calculation and bending moment calculation, and for the values of the shear force and bending moment we are going to draw the diagrams for their respective values. Here, according to our given data, number 1, here it is given is a cantilever beam with a 2 UDL loads. A cantilever beam with 2 UDL loads of magnitude 4 kilonewton per meter and 3 kilonewton per meter for the span of 2 meters. This is for the span of 3 meters. Next, total load on beam. Here we are having the UDL loads, so that we have to convert them into the point load, so that we are going to have the load in kilonewtons. While converting from the kilonewton per meter into the kilonewton, so that we have to multiply the UDL load into the span which is going to acted here. When we multiply the UDL load into the distance which it is covered by this UDL load, so that we're going to have the UDL into only kilonewton. Here 4 kilonewton per meter is multiplied with 2 meters. When we multiply this, the meter going to cancel and we remain with only kilonewton. That we are going to find here. That is equal to 8 kilonewton, and another load is 3 kilonewton per meter, and the span is 3 meters. Meter going to cancel, that is 9 kilonewton. The addition of the both UDLs or both loads on the beam is going to our total load on beam. Here that is 17 kilonewton. The total load on beam is equal to 17 kilonewton. Next, number 3, equating upward reactions is equal to downward reactions. As we knew earlier that for the fixed beam, for the fixed end of the cantilever beam, we are going to have only one reaction, that is RA, and one more, that is moment about A, and reaction RA. For this, while equating, we are only having only RA reaction, that is RA, that is in the upward reaction. RA is equal to the total load on beam, or the total loads are equating downwards. The same here we are going to find here all the same, that is 17 kilonewtons. The downward is equal to upward, or upward reactions is equal to downward loads or downward reactions. Next, shear force calculations. This is a diagram. As we know that we are solving with a standing method. Here shear force at A is equal to shear force at A, that is if you stand just left to the A, then it is going to the value shear force of a value is equal to 0 kilonewtons, because if you stand here just left to the A and looking to the left side of the A, and here we don't find any type of reactions or any type of loads that is going to act on this beam, so that we are going to consider it is as 0 kilonewtons. Next, shear force at A, just right to the A, just right to A, just right to the A, that is here itself, just right to the A, that going to find that we are going to find with a RA reaction in the upward direction, that is RA, the value shear force at A, just right to the A, that is only we find RA, the value of RA is equal to 17 kilonewtons. And next, shear force at B, here shear force at B, here we are having the udl load which is acting for the span of 2 meters from A to B. That if I stand just left to the B, just left to the B, I am going to find the reaction RA and a udl load, but here the udl load is uniformly distributed throughout the span of A to B. We cannot divide the udl, so that we are not going to consider the udl load of 4 kilonewton per meter, so that for the left side we are going to have RA reaction, the value of RA is equal to 17 kilonewtons. And next, if I stand just right to the B, just right to the value of if I stand just right to the B, then we are going to have the reaction RA, that is in the upward direction, and a load of udl load, that is in the downward direction, so that I am going to take negative sign minus 4 into the distance which is going to act here, that is 2 meters, that is equal to 17 minus 8, that is equal to 9 kilonewtons. Next, shear force at C, here up to the C we are going to have only two reactions, two loads or two reactions, that is RA and a udl, that is 4 kilonewton per meter. To B and a C, we are going to have only the reaction and the load udl. Next, so that the same 9 kilonewton load is going to act for the B to C. And next, at the rate of D, here we are having C and D. If I stand here, we cannot divide the udl, so that we cannot have the value of shear force at left, but it is going to decrease the value of shear force value by the, as we discussed earlier, here this is 3 kilonewton per meter, and if I take the shear force at here, if I take the shear force at C, I am going to find the total 3 into 3, that is equal to 9 kilonewtons at C. If I am going on to the D, let us consider this is a point D at the midspan of the C to E. Here I am going to have the same, this is udl, so that 3 kilonewton per meter if I need the shear force at shear force at D, I am going to multiply the load into the distance up to here, that is 3 into 1.5. The distance, this is 3 meters, so that half of the 3 meter, that is 1.5, that going to be 4.5 kilonewtons. If I am going on to the D from C to D, here from C to D, the shear force is going to decrease gradually to the 0. Here the same manner, in this shear force at a D, shear force at a D, shear force at D to the left side, it is going to decrease the value, so that I am going to consider the midspan of the beam for the convenience, that is at the midspan the value is 4.5, and shear force at a D to the right side of D. If I stand right side of the D and looking left side, so that I am going to find the value. Here it is 9, up to here it is 9 minus the 3 into 3, that going to be 9, that going to be 0 kilonewtons. By this values of 0, and this is not a value, but for the convenience, for the why it is going to be inclined, so that I am going to discuss it here. And next, by these values of 0 and a 9 and a 17, we are going to draw the shear force diagram. Next, we are going to find the values of bending moment. Here at the rate of D, it is 0. Moment about D is equal to 0. Here moment should be have that force and its perpendicular distance. Here we don't have any type of forces or any perpendicular distance, so that moment about D is equal to 0. And at the rate of moment about C is equal to, here it is C, that we are having a force of 3 kilonewton per meter into 3, and when it is going to be multiplied with 3 kilonewton per meter, it is going to multiplied with the distance which is acted, it going to convert as point load. The point load exactly acts at the center of the span. Here it is going to convert as a point load, that is at the center, that is distance is 3 by 2. Up to here that the distance is 3 by 2, so that this is going to multiply with 3 by 2, because the moment taking with 3 by 2 distance, the value is 9 kilonewton into 1.5. Here moment about B is equal to, we have to take the moment about B from D to B, that is here we are having a load, that is 3 kilonewton per meter, and multiplied with 3, which is going to convert the UDL into point load, and this is going to be multiplied with the distance of 3 by 2, and here we are having up to B, the distance is 1 meter from B to C, and C to D is, we are going to take the moment from 3 by 2 distance, and for the distance of 1 meter, it going to be add in the 3 by 2 distance of, here 3 by 2, and the moment the perpendicular distance is 3 by 2 plus 1 meter, so that here 1 meter, that 9 and a 3 by 2, 1.5 plus 1, that is 9 of 2.5, that is equal to, these are all in the negative, because as earlier we discussed that this is a cantilever having a hugging moment. One side is a anti-clockwise direction and another side is also a anti-clockwise direction, so that here we're going to have the hogging moment, that is negative bending moment. Here moment about A, similarly we're going to take for the same manner. Here it is 3 kN per meter, this is 3 meters and this is 1 meter and this is 2 meters. That is equal to 3 kN per meter is multiplied with 3 and which is converted as a point load, and it is going to be taking the moment at the midspan of the beam with a 3/2 distance here from here, and from here to the A the distance is 2 plus 1 3 and a 3/2, that is 3 meters. And next this is also negative, this is negative, and next we are going to have only one UDL, that is 4 into 2, which is going to convert the UDL into point load, and taking the moment to the A, that is 2/2. That value is minus of 9 or 4.5 minus 8 of 1, that is equal to minus of 36. Value is equal to minus 48.5 kilonewton into meter. By these values of moment about A, moment about B, moment about C and moment about D, we are going to draw the bend moment diagram and shear force diagram with the respective shear force values. Here for the shear force at left we are having 0, shear force at right we are going to have a 17 kilonewtons. The value is here 17 kilonewtons. As gone to the B, we are going to decrease the value of 17 to 9, that is in the inclined manner. This is 9, and from B to C we are finding that no loads, so that we are going to have a same constant value, that is 9 up to C, and for the value at D, that is 0 up to here, it is where it is some value, that is 1.5, so on. When we go into the right side of the D, we are going to find the values 0, and similarly for the bending moment here, that is in the hogging moment, so that we are going to draw the hogging moment in the negative direction, that is moment about D is equal to 0 and moment about C is equal to, that is 13.5, and moment about B is equal to, that is 22.5, and moment about A is equal to 48.5. Joining the points, as from A to B we are going to have the parabolic like a curve nature, because it is having a UDL like this curve nature. From B to C we don't have any type of loads, so that it is going in a straight, and from C to D we are going to have in a curve manner. Joining the lines, this is our bending moment. The value here it is maximum. Bending moment maximum is equal to moment about E, that is values minus 48.5. Here we should not write the values with a negative sign, because already we completed the diagram in negative coordinate, that is here 22.5 and here that is 13.5 and it is 0. I think so this is very easy process for beginners and for everyone. If you like this video, please do like this video and share it to your friends, and please do subscribe the channel and hit the bell icon for my regular updates on strength of materials. Thank you.